Hello there, and welcome to another episode of Vault Talk. I want to say thank you for joining me. And if you remember in a previous episode, I brought Glen Trew with me to talk about the dish timecode boxes. This is a new revolutionary way to get timecode, and it thinks about timecode a little bit differently. But when we were discussing, we actually had a couple different questions. So I wanted to bring Glen Trew along in space today, but I wanted to bring another guest. Glenn, how are you doing today?
Doing fine, doing fine.
Excellent. Well,
Thanks for
thank you for
having me
joining
back.
me again. What I wanted to do is, we had a couple questions about the innards of this timecode box, leap seconds, and all of these other technical aspects that are important to these boxes and how the timecode works, but is also part of the whole magic of this ecosystem because they're so technical that it takes all of that away from us and makes timecode easier for people on set, right?
Oh, exactly. And there were some things, some questions that we asked of ourselves that we couldn't answer in the exact detail. So we thought, what better way to get those questions answered than to bring the scientist himself, Ari Krupnik, who was the inventor of the dish system. And so
Absolutely.
we have him here today.
Absolutely. And he is right here. Ari, we'd like to say hello to you. Thank you so much for joining us on the show today.
Well, thanks for having me.
Absolutely. And in fact, why don't we just bring in everybody so we can all say hello and have a group chat? Ari, I want to talk and start off by saying, how are you doing? And, how did you get into sound? I know that you are originally a Tesla employee. Is that correct?
I did work for Tesla.
Excellent. Well, I wanted to ask a little bit more about that relationship because I'm a big fan of Tesla. I do love Elon Musk. I enjoy his little rants online sometimes. It's very entertaining. But the one thing that I really want to dive into is the differences between this transportation and artificial intelligent world that you've lived in for so long. And now you're kind of coming into the entertainment industry, which is a completely separate entity in itself. What can you tell me about the differences of these two industries?
Well, thank you for asking that. Because that actually is how I came into film. I came up through software engineering. I spent 15 years in Silicon Valley doing different startups, including Tesla. Um, and I started looking at film, and I said, people who make film have similar problems to what we have kind of are dealing with. You take a bunch of people with creative people with non-overlapping skill sets, and you get them all together, and they will produce something that they need to work together to produce something that's coherent and has a story that people can follow. And in the end, they're going to make a very large binary file that you're going to watch on your phone. So in some ways, filmmaking has become very much a software process. You used to have all these different types of equipment. If you were an editor, you had a flatbed editor. If you were a screenwriter, you had a typewriter. But now everything is happening on laptops. Everything is happening on computers now. And so the process has become essentially a software process except for the principal photography. Um, and so I said, maybe there's some lessons that we learned managing large software projects that we can bring this knowledge into the film world. And when I started looking at film, the thing that became apparent to me immediately and was a big surprise to me was how much manual labor goes into production. I was completely unprepared for the sheer amount of, how much you need to do by hand. And I'm like, I'm used to computers doing this stuff for me. I'm used to automation. We get mileage out of automating processes. You don't have to say, well, click this button, click that button. We write a little program that does that for you, and then it does that every time repeatedly, and predictably.
Wait a minute. Are you the guy that built a robot to get your lunch from the fridge during your lunch break? Tell me the truth.
Yes, yeah, that is me. That
Oh,
him
good.
is me.
I knew it. I knew it.
And so when I started visiting people on sets, and I saw people using clappers, and I'm like, why? What do you use that for? And people tell me that they still use the actual clap to sync sound, and I thought it was a joke. I thought people were But no, they say this really is. I mean, we have this and that and every other kind of thing. But in the end, this is our main backup. This is the thing we fall back on, and we do this thing where we drag the sound by hand until it matches with the clap. And I said, "What is this? 1929?" So I said maybe that's a thing that I can help automate. And so I looked into what was available, and I looked at some of the timecode systems that were available. And the thing that was uh, immediately noticeable was the learning curve to use them was very significant. Um, they have all kinds of switches and buttons and knobs, and you have to turn them just so to get anything to come out. And if you get one of them wrong, well, some of them it doesn't matter if you get them wrong, but some of them you get them wrong, nothing happens. And so the experience, especially from the smaller crews that I've heard a lot, the independent crews that I've heard a lot is, yeah, well, we tried time code that one time and it didn't work, and then it was even worse than not having anything at all because now we didn't even have the clapper, so now we have to do everything entirely by hand, and so we're not doing this again. Um, so if you're in a production that can afford a sound guy or girl who knows what they're doing, time code is great. But if you can't, then you're just basically back to where we were in 1929. And so I thought there's got to be a better way of doing that. So that's what we tried to do. We tried to come up with a timecode system that didn't take a PhD in sound design to use, something that you just turn on and plug in, and it works.
Yeah, on the last bit we did, just with Thomas and I, we mentioned that the simplicity was a very high priority for these systems.
Yes, sir.
In fact, on what we call the standard model, there's two models: the standard or the original, and then the pro. But on the standard, you can't do anything with it except turn it on. In fact, the only way you can turn it on is to plug it in, and it turns on by itself.
Right there.
That is accurate. We started calling it DM for DSLR and mirrorless. The original model, because that's really the crowd that is designed for. It's designed for cameras that don't have a hardware timecode input. So you would put the timecode on an audio channel, and so that's the type of cameras that would usually be the target audience for that.
Exactly. Yeah. And one of the things that I actually want to bring up is because now that I've had these in my hands and I've played with them and I understand what they're for, because like everybody says, even Glenn brought up earlier, it's like, oh, that's interesting. I don't really understand it. Oh, now I get its use. Now like that epiphany happened in my head too. And so I'm trying to show other people, out there, hey, check out this box. Take a look at what it does. Look at what it can simplify for you, what it can do to help your productions when you need that niche timecode solution. And a lot of people will be like, yeah, but it doesn't allow me to customize my timecode or change it to whatever number I want it to be. But why? You don't have to do that. The whole point of timecode is to get dead accurate sync, not to create more variables that other people might screw up, right?
But now, of course, with the Pro model, you can select the timecode frame rate.
Exactly, yes. Now this is the Pro model right here if you guys want to take a peek here.
Yeah. So just to review a bit from our last episode, the standard or the original, Ari, what did you say that the official name
DM.
Dish DM.
The Dish DM.
Okay. That one always outputs 30 frames timecode. Is that correct?
24.
Okay. Okay. Well, that's a correction because I think on the last episode I said 30, but it's always 24.
It's equally unusable in the sense that there's nobody who actually shoots 30 frames per second, and nobody shoots 24. Not on that kind of equipment.
Right. But a second's a second, and they're both going to flip over to the second at exactly the same time.
Yes, sir.
Okay. So the original outputs 24 frames at all times. The professional model or the Pro model does have a rotating selector switch, so you can choose the frame rate that you want to have stamped when you're jamming a recorder or a camera. So from 30 down to 23976, drop and non-drop frames for 2997. So all the standard frame rates are available on the Pro model.
These are the ones that you're going to see on your professional sets when you've got the bigger cameras that have the B and C timecode input. this is the one that's going to be pulled out, because you're already going to have those conversations with people where they're like, this is the time code of our chute, dial it in and plug it in.
And also in the last episode, we mentioned that there had been productions prior that tried to use GPS for long distance syncing, and they had some unusual, unexplainable at the time sync issues where they were out of sync, and it didn't go as planned. But you were explaining to me that it's because leap seconds were not considered in the calculation, but the dish system does consider leap seconds, so that issue can't happen.
That is correct.
So can you explain, I know it could probably take weeks to get into full detail, but explain a little bit about leap seconds.
Well, so the rotation of the Earth is not uniform, and some years are a little bit longer than others. And so once a quarter, the people who make these decisions get together around a big conference table and decide whether or not they're going to add another second at the end of that quarter or the following quarter. These things happen about once every year and a half. They're unpredictable and non-uniform. Sometimes you can go 3 years without leap seconds. Sometimes you get 2 leap seconds in a year. And civil time is tied to these leap seconds. So this is a UN body that makes these decisions, and then all the countries in the world adjust their clocks. And the leap seconds are they're an awful thing, because what happens when you introduce a leap second, the last minute of December 31st ends up having 61 seconds in it. And most clocks cannot do 61 seconds, so they will just replay the last second twice. So it gives the appearance of time going backwards at the end of the year. So you go to you're on December 31st. It's 1 minute to midnight, and at the end of that minute, that last second, you don't go to January 1st. You go back to
Still 1 minute.
23:59:59, and so it messes up computer systems, and it messes up anything that relies on things happening in a particular order. So if you have financial transactions, it messes them up, and it's a big problem for a lot of people in a lot of different areas, and in particular if you have a clock that doesn't know what the correct offset is. It will be off the real time by some integer number of seconds. It will report that the beginning of the second it report correctly, but depending on how out of date its information is about how many leap seconds have happened since the beginning of leap seconds, which happened in actually, I don't remember when they introduced the first leap seconds.
Yeah, but I guess
I want to say in the 70s. So you can have different receivers that have different ideas about how many leap seconds have happened, and so they will be off from each other by an exact number of seconds. So you might have one that's 3 seconds ahead of another if you don't correct for that.
Right. So the dish system considers that and corrects for it so that you don't have an offset.
Yes, sir. So what we've chosen to do is report time in what's called International Atomic Time, TIA, and this is the time without any leap seconds. So in 1959, when they first started using universal coordinated time, after that they started adding seconds that to the civil time, but the atomic time stayed at however many seconds happened since then. You divide that by how many seconds there are in a year, and that's the time that happens. So that time never changes. It never goes back. It never adds those leap seconds. It's the time as if no leap seconds ever happened. So if you have two systems that are both on International Atomic Time, you are guaranteed that they will be in sync even if they don't know how many leap seconds have happened to universal coordinated time since
Right. So if people have heard rumors about, well, GPS, and we'll get into this, so the fact that the dish system is not just related to GPS.
that is
We'll
also
get into that
correct.
in a second. But if people hear the rumor about GPS is not accurate enough for long distance syncing, that was a misunderstanding of a problem that was happening a while back, uh, because leap seconds were not considered in the calculation.
It is
So
still something that happens. It's less common now because now you mostly deal with GPS time on phones, which have a pretty good way of tracking all this external information. But if you have a standalone GPS receiver, the first time you turn it on, it might be off by a second.
hmm,
Eventually, it gets enough information from the satellites to know the correct offset, and it will correct itself. Uh,
hmm.
and it will go back that many seconds, and it will get on the right time. But it is still a problem you can get with standalone GPS receivers even today, if you don't account for it correctly.
Right. Okay. Okay. But the short answer is there is no drift like the rumors might suggest
No,
from
sir.
a historical problem many years ago.
No, sir.
Um, so the other thing is,
It's incredible.
people are gonna assume it's GPS, right? And from what I understand, it does consider GPS and some of its information, but it also considers information from other satellite systems.
That is true. Well, you say people assume, but you'd be surprised how many people assume that we have our own satellites.
Ah,
And I just kind
wow.
of hate to piss on their parade. And it's like, can I, can I, can I imply somehow that we actually own our own satellites in orbit? That we're
We had a theory yesterday, Glenn, when we were doing a test that you know how Elon put a Tesla Roadster up in orbit?
Mhm.
We had a little theory that he put one of his satellites in the trunk and it just kind of opened up and now it's just out there and nobody knew about it.
Yeah.
I don't
Well, if people want to believe that, it's I don't think any harm can come from it.
Right?
Uh,
But no, we don't. That's the other question people ask is are there any subscription fees? Do they expect if it's a satellite, then there are subscription fees like with a satellite phone? So no, there aren't. These are all public signals that we're listening to, and GPS is one of the systems we're listening to. But we're also listening to a number of other systems. We're listening to the Russian GLONASS system, and we're listening to the European Galileo system. And in other parts of the world, you can also get additional signals. There's a Japanese system, there's a Chinese system that all have very accurate and precise time transmissions, and we listen to all of that, and we get the best signal out of that um, that we can discern. And listening to multiple systems makes us more. It increases what they call availability. It means that there at any given moment there are more different satellites that are in sight that you can listen to, even if you are. Um, a problem with early GPS was what they would call urban canyons. If you were in the middle of Manhattan, you needed to have satellites exactly overhead, or you wouldn't get a signal between the tall buildings.
Mhm.
And the more satellites you can listen to, the less that becomes a problem. You are more likely to get satellites at the angles where you can see them.
right. Is there a place on the globe where the dish receivers would not work?
Not on the globe. If you go underground, if you go deep underground, if you go into a missile silo, you're not going to get a signal. If you dive in a nuclear submarine, or any submarine really, doesn't have to be nuclear. If you go underwater, you're not going to get a signal.
Mhm.
If you are going faster than 500 miles an hour, ITAR regulations make the GPS turn off. Um, Other systems maybe not, but GPS receivers will turn off because the State Department wants to make sure you're not building a cruise missile.
Interesting.
So if you go over, there's an altitude limit also that escapes me right now, 18,000 feet maybe.
Yeah,
If
I
you
was
go
going to
above that,
ask you that. I heard that one of the new Mission Impossible movies, they may actually film in space. They want to take him to the International Space Station, Tom Cruise. Would this work out there?
well, we'll just have to send them a free unit and find out.
Good idea. I think that's a good idea.
There's nothing like field testing.
Right, exactly.
I think they'll be able to afford to buy a couple.
Yeah, maybe, just here,
Okay, scratch the free then. Yes.
yeah, right.
So it's good all over the globe. So the illustration I used in the past was let's say we have 10 crews, and they're scattered all over the globe. In Los Angeles and New York, and even different parts of Los Angeles, and then another crew in Beijing, and somebody in Africa somewhere, and they need to be in sync with each other because who knows, maybe they're covering up the same international event, or maybe they're involving teleconferencing live, which because of different lag times, you can have quite a few frames of offset that you could definitely see a slip in lip sync. With this system, everybody in all those places would have exactly the same time code. And using that time code in post-production, you can bring all those sources with different lag times back into perfect sync.
That is accurate. And you can be 10 feet away, or you can be 10,000 kilometers away. And you'll be in perfect sync always.
Yeah. And another thing I pointed out is that you can have you can have all of your timecode boxes, like on the cameras and on the sound equipment on your slate, that they can all be dish systems. However, if somebody already has a system that they're invested in, maybe they have 5 to 10 boxes for different cameras and slates and recorders, you can still have the same time code in all the different parts of the world by having a dish receiver and then jam syncing from that dish all of your other equipment. And then voila, everybody's in sync with all their devices.
That is also accurate.
Yeah,
So,
it pretty much works with any budget that you're working with. If you can only afford one box, but you have other timecode devices, just jam the other boxes on set and your ecosystem is still going to work. Or, put one on everything and just call it a day. That's what I would rather do, to be honest.
And that's really the use case that we're happy to accommodate people with different use cases. But the main use case that we see is people getting a dish on every recording device, one on every camera, one on every sound recorder. And then you don't need to worry about cloaks that drift, because camera cloaks can drift. Recorder cloaks are usually better, but camera cloaks drift, and so you need to rejam them every once in a while. If you leave the dish on your camera, then it jams it all the time.
Right. So I think maybe I should comment, because since we're still in the middle of COVID, distancing, and which means no getting a haircut.
Or doing what I did.
Okay. So okay, we see your solution there. Thomas, I don't think you and I have a solution yet, right?
Yeah, I just kind of trimmed over the ears. I can't have the ear hair over the top. Oh, so you just got to do the sides. You know what I mean?
Yeah. So anyway, maybe next time we're on, we'll be able to get a haircut.
Absolutely. Well, do you guys want to plug in this box and show people yet again? On our previous video, we showed the sync between two states. Why don't we show a triple sync?
I'm going to get my dish box. I'll be right back.
Love it. So what I'm going to do is I'm going to take my Dish Pro box, which is the BNC version, and it's set to 23.98 right now. And I'm going to plug in my BNC cable.
So I don't know if you mentioned it or not, Thomas, but I'm in Nashville. You're in Los Angeles.
Correct.
And Ari's in Dallas, I believe, right?
That is correct.
In Dallas. And we have not, we're not connected with anything. We have not jam sunk our dish boxes, because you can't jam sync the sync boxes.
Yeah, we don't have that long of a cable.
Yeah. So we're going to plug in our boxes.
So all we did was turn our boxes on in our respective areas. And the slate, if you notice mine, I had it, and it was set to zeros. That's because it's in read mode. So now you can see that it is reading the time code that's coming from the Pro box. We've got 1946, 49, 50, 51. Exactly. Now, if you're seeing any bit of a delay, it's because of the latency of the physical camera system that we have. And you can see that, Ari, you have something new that you're holding up. Do you want to talk a little bit about this? What's going on up here?
So we're toying with the idea of making our own smart slate. Part of the part of the difficulty of explaining dish to people is there's no display on it because you don't need a display. It always shows the same thing. But it's kind of hard to visualize what it does. And so we made this slate. On the back of it, it just has the same board that you would find on inside a regular dish, and it outputs all the numbers that that dish would have. So you have the time here, and you have the frame rate here, and then you have the date, which we also know, and we put the date in user bits, and so you can see. I don't know how well you can see this with my
with your lighting.
Little
Yeah, we can get the idea. Yeah.
Mm-hmm.
So we just kind of wanted to build something that shows that visualizes a dish, and then if you change the frame rate, yeah, sorry about that. If you change the frame rate, you can see the frame rate change as well.
Now at 24,
Mm-hmm.
25, 2997,
and drop frame and 30.
Yeah.
Very
So we built that as a demonstrator, and then people started asking if we're going to make that as a separate product. And if there's enough interest, we can certainly build that. And
That's really interesting because then you have a slate that you don't have to jam.
Yeah, you
That
just
is
Turn it on.
You literally, as a camera AC or even as your sound team, you say at the beginning of the show, "Here's your slate. Keep it. Change the batteries if it needs to." That's amazing because it's one less thing to honestly forget when you're amidst everything. And like you said, Glenn, with all of the COVID stuff that's going on right now, it's there's going to be a lot more responsibilities in sound for disinfecting, for cleaning. If anybody hasn't seen it yet, you definitely want to take a look at Cannibal Industries. They have some new disinfecting products that use ultraviolet light to kill the germs and to keep us safe on set. So I cannot tell you how many times we're going to be like, oh my God, I forgot to get the slate. But if they just have it, they can put batteries in it, turn it on, and then you're good to go.
Yeah. Yeah.
and you never need to jam anything. It's always on the same time.
It's a beautiful thing.
Something we mentioned last time, but not this time yet, is that the time of day that it always outputs is, I guess there's several names for it, but universal time, UTC, Greenwich Mean Time, which is also GMT. And in aviation, we use the term Zulu, Zulu time, which is basically what the time of day is in Greenwich, England. And Ari, you can probably get in more scientific detail than that.
No, I think you're good. There are different names, like you're saying, and sometimes people think that one is better than the other. They all refer to the same thing. GMT fell out of favor because it is very England-centric, and other countries, mostly France, opposed to having something so British. So now we just call it universal time, although it's still essentially tied to time at the zero.
So it's just a name difference. It's still the same time.
Yeah.
So like
GMT and UTC are exactly the same thing.
Yeah, Celsius and centigrade.
Yeah.
And that's what you see here. That's why you're seeing 1950. So that means that it's almost 8 o'clock in Greenwich right now.
Yeah.
Yep.
And I'm sure that a lot of people have become used to seeing the actual local time of day on the slate, and they've kind of gotten lazy to use that time for knowing what the first shot of the day was and what time lunch is supposed to be and all that. So they use it as a clock. I think it's just a matter of getting used to a better system, which is knowing what time it is everywhere. And it's very easy to calculate local time if that's necessary. But
something that you may want to keep in mind is that if you set the camera clock and the recorder clock roughly, you don't have to be very accurate, but roughly to local time, you will the file timestamps, the last modified time on the files will still be in your local time zone or whatever time zone you want them to be in. So if you need to know what time of day you shot that particular, you took that particular shot, you still know that even without doing any of the math.
yeah.
But the good news is that you never have to worry about, are we on daylight savings? Are we on winter time? Did we move to, did we cross a state line and we're in a different time zone now? Are we in a state that does daylight? Are we in Arizona and it doesn't do daylight savings? So,
I've
Never have to
never
worry about
understood that to this day. You could explain it to
it.
me and I'll
No,
forget it
nobody
tomorrow.
does, and the good news is that now you don't have to.
We don't have to. Exactly. Yeah, that is one of the things that's really interesting about that product for anybody that's listening, because this is like the anti-timecode box. It's literally the box that says forget everything that you know about timecode. You don't need to know anything about timecode except for put in batteries and plug it in and turn it on, because it's going to do everything else, and it's going to simplify it to the point that you're not going to have the opportunity to screw up your time code and cause more of a conflict in post-production because they're having trouble syncing things up.
And you can give it to the camera department. You can give it to the PA. There's nothing to, like you're saying, there's nothing to mess up. There's no buttons to press. It's not going to happen. And also for smaller crews that can't afford someone um, who is an expert at time code, a full-time person who can do that. Smaller crews usually sound is just somebody, just somebody who got the job just because nobody else knew how to do it. Um, and you can have time code even on these smaller productions, even when you can't have a dedicated sound person or dedicated time code operator.
Yeah. Yeah. To sum it up, I think, especially now talking to Ari about the inside of this device and how it all happens, it can be very complex, very complex. But Ari is not only smart enough to figure all that out, he's smart enough to make it extremely simple to operate.
Yeah, you took one of the most complicated things in production. I mean, I can't tell you how many fights in the past 15 years I've had with, camera operators, or I don't want to say fights, disputes, where it's like, no, that's not what it's supposed to be, where just having this, it'd be like, let's just move on with the day. Let's just, should have talked about this beforehand, but we're doing it now type of deal.
Also, I think we've all gotten the phone call from post-production saying, there's time code drift.
Oh man,
And,
the pit in
and
the stomach that
very
happens
rarely,
from that. Whew.
I've had to field so many calls for myself and other people.
Yep.
And it's almost always something besides the sound, master generator time code.
Mm-hmm.
But now when you get that call, there's some time code drift. No, there's not.
Yeah, impossible. Take it up with the satellite in the sky.
Yeah.
Very good. Well, Ari and Glen, I want to say thank you so much for joining me today on another Vault Talk to dive into this box more. It's so funny because it's such a simple box, but there was so much to talk about. So I love that we had the opportunity to bring Ari, the manufacturer, and keep doing what you're doing, because this is an exciting new product, and I can't wait to see the slate too. Maybe you can send one our way when you're done working on it.
I'll be happy to.
Awesome. Well,
So, Ari, are these yet available? And if not yet, when do you expect them to be available to ship?
So we have our lead time right now is 6 to 8 weeks.
Okay.
And then it really is up to you, Glenn, when people can go on trueaudio.com and buy them.
Well, I'm certainly behind these because they offer something different and something very useful. So True Audio will be stocking these devices. So I would expect to have them available in 6 to 8 weeks from May 21st, 2020,
Yes, sir.
Zulu time. And this is a dated production, so you may be listening to this a year from now. But anyway, we expect to have them available for sale very soon.
And we're here at Video Mantis as well as at True Audio for all of your retail needs and for any questions that you have. So if you pick up these boxes and you do have any questions, we're here to help you. Thank you so much for joining in, and we'll see you on another episode of Vault Talk soon. Take care.